Alright, class, this week this is a video reviewing lesson 2.1 on angles and congruence. We are particularly interested in, on this lesson, our special angle pairs. We reviewed some vocab that we had previously covered. We covered adjacent angles, where a pair of angles that shared a side. And numerically, the numeric relationship here is that our adjacent angles could add to any number. I could have an angle that's 5 degrees next to an angle that's 10 degrees. There is no rule about what the adjacent angles add up to make. You'll generally see it in the problem. Our linear pairs were two angles that add to equal 180 degrees. As a reminder, our vertical angles are congruent, meaning equal. And then we had one new word here, which was angle bisectors. Angle bisectors cut an angle in half, making two congruent adjacent angles. We'll see a problem involving each of these vocab terms in a second. Our approach to this sort of problem solving is we're going to first off look to identify some relationship between two angles. And then once we've identified that special angle pair, once we've identified it, we're going to use the relationship that we know about it. Whether it's adding to some number, whether they're equal, whether they add to make 180, or whether they're going to be congruent, also equal. Starting with this one here, we see two angles that are adjacent to each other. Just as a reminder, we also know that this is considered complementary because we see that they're making a right angle. So we could say that we have complementary angles. Or they're adjacent angles. They are at least adjacent angles. And because we see this square in the bottom of our picture, we know for a fact that they're making 90 degrees. Adjacent angles adding to 90 degrees. So we'll write the relevant equation. Whether we think about it complementary or this way, we'll write the equation 7n minus 3 plus 37 equals 90. We'll then do some simple algebra. We'll combine our minus 3 and our 37. And we'll work to solve for any variable or missing angles in our problem. We've got 7n, then negative 3 plus 37 is 34, equals 90. We'll subtract 34 on both sides. We'll get 7n equals 56. Dividing by 7 will give us n equals 8. We could then use our value of n to confirm the size of this angle here by plugging n equals 8 into 7n minus 3. We'll get 53. We could also have known that by going, if the entire picture is 90, if the entire picture is 90 degrees minus 37 gives us 53 degrees right here. We're going to do something similar over here. On this problem, I asked you to try it out with a similar approach. Identifying this relationship here. I see 1, 2, 3 different angles, but they're clearly together making a straight line. We could give this a fancy name. We could call it a linear triple, because it's, instead of a pair, it's a group of three. We could say it's adjacent angles, three adjacent angles. Whatever we wish to decide, we can see it's making a straight line, so it's adding to equal 180. We can say we've got 57 degrees plus, there's that square again. That square is an indicator that we've got 90 degrees. Plus 8q plus 1. And we'll solve this by doing some more steps. We'll combine our 57, our 90, and our 1 into one number. We'll simplify our equation into 8q, keeping the 8q, plus 148 equals 180. We're going to work to get 8q by itself, which means subtracting 148. Give us 8q equals 32. Divide by 8, q equals 4. Since we know q equals 4, we could plug it into here to find out the missing angle. We'll find it is 33 degrees up here. We could have approached it another way to find this 33 degrees. We could have found it by going 180. The entire line should be equal to 57 plus 90 plus our missing angle here. And the only thing that fills in that makes this equation true is 33. So we dealt with adjacent angles, we dealt with linear, technically linear triple, but you could do the exact same sort of thing with a pair of angles as well. We'll take a look at 15. We'll identify its relationship and solve to find out what x equals. Well, I see two lines crossing each other, so to me that means I've got vertical angles. I see my VA, vertical angles. That's going to tell me that the 120 degrees here and the 2x minus 10 are the same size. Remember, vertical angles are congruent. So we get to set 120 equal to 2x minus 10. And we'll solve for x by adding 10 to both sides. We'll get 130 equals 2x, or x equals 65. If we were asked to find one of the other angles in this picture, one of the other values of the other vertical angle pair, we could find that by covering up part of the picture and seeing these two angles make a straight line. They make 180 degrees. So we go 120 plus what number makes 180? Well, that's just 60 degrees. We're going to take a look at 6 and 10, and that'll be the end of this recorded video. On 6 and 10, we have to watch out for one important fact here. First off, we see BA and BC are opposite rays. That's a fancy way of just saying we have a straight line. We have a straight line. But more importantly, angle BE, ray BE bisects angle ABF. We'll highlight that briefly. So we've got our angle ABF, and we have BE bisecting it. From our definition of an angle bisector, it's going to cut the angle in half, making two congruent adjacent angles. These two angles here are going to be the same size. ABE is going to be congruent to EBF. ABE here, coloring it in red, is going to be congruent to this angle here, coloring it in black. ABE will be congruent to EBF. We will set them equal. Congruent means equal in measurement, in size, in angle degrees. We'll write that 2n plus 7 equals 4n minus 13, and we'll solve this by getting all of our variable terms to one side and all the constants to the other. We'll add 13 to both sides, and we'll subtract 2n from both sides to do so. The minus 13 and the plus 13 cancel out, that's why I'm crossing them out. The 2n and the minus 2n will cancel out, that's why I'm crossing them out. We're left with 7 plus 13, which is 20, equals 4n minus 2n, that's 2n. That just means that n equals 10. And now we want to check that we've answered our question. We found that n equals 10. Is that the measure of angle ABE? ABE, we're told, has this equation here, which is 2 times n plus 7. So we're going to have to take our answer for n equals 10 and plug it in. The measure of angle ABE will equal 2 times our 10 plus 7. That's going to be 27. What that means for us is that the angle here in red is 27 degrees, and the angle here in black is 27 degrees. They're going to be the same size. If this is 27 and this is 27, our blue angle, ABF, would be 54 degrees. Number 10 is a similar situation. We're told ABF, our blue angle, is 8W minus 6. We're told ABE, our red angle, is 2 times W plus 11. We said that was a little weird, so we went ahead and distributed it and said we had 2W plus 22. And we're being asked to find the measure of angle EBF. Well, first off, let's just note ABE and EBF are supposed to be the same from the very beginning. BE, the ray, was bisecting angle ABF, meaning the two angles that were there were congruent. ABE is the same as EBF. So if we know EBF, or if we know ABE, we can find, if we can find ABE, we can find EBF as well. angle ABE is equivalent. So, what we're going to have to do is think about how our red angle is related to our blue angle. What you need to remember is that our blue angle was being cut in half by this yellow line. So if we comment on that fact, if we talk about finding half of our blue angle, half of 8w minus 6, half of this blue angle should be the red angle. Half of ABF should be ABE. 1/2 of HW minus 6 should equal our 2W plus 22. Now that we're here, we can go ahead and solve this. You might have written something else differently, and we might have written something else differently because there are multiple ways to talk about and write a sentence involving this statement. But we'll solve it by distributing the 1/2. Half of 8 is 4. Half of 6 is 3. Now we're left with 4w minus 3 equals 2w plus 22. We take similar solving steps like we did up here. We'll subtract 2w from both sides. We'll add 3 to both sides. We'll be left with 2w equals 25, which means w equals 12.5. Now that we know what w is, we can use it to find ABE. And since AB is equivalent to EBF, we'll have our answer as well. We'll find angle ABE by taking our answer and just plugging it in to here. The measure of angle ABE is equal to 2 times 12.5 plus 22. That's going to be 25 plus 22 will give us 47. So our measure of angle ABE is 47 degrees. The measure of angle EBF would be 47 degrees as well. You had a homework assignment with this page that was altogether 16 problems.